Hello, everyone. Welcome to our Break-Free Lunch and Learn webinar series. I'm your host, Laura with Videre Creative, and today's episode is all about faster builds, accelerating construction timelines with Rebel sensors. For anyone new to Wavelogix, here's some background info. Founded in 2021, Wavelogix partnered with the Indiana Department of Transportation and Purdue University to enhance road and bridge reliability while minimizing traffic disruptions. Our patented Rebel concrete strength sensing system offers real-time in-place concrete measurements, streamlining project schedules and reducing costs. Our speaker, Joe Turek, is a seasoned engineer with the BSEE from Notre Dame and an MBA from Northwestern. He holds 5 patents in microwave telecommunications technology and is a registered professional engineer. Now I'll hand it over to our presenter, Joe Turek.
Thank you, Laura. All right, let's get this road on the show here. Knowledge is power, right? We've all heard that before. In our particular case, with our sensor technology, knowledge of strength is what's really important that gives us the power to do things like optimize our process flow, faster operations, reducing labor waste by increasing productivity and efficiency, and scheduling ease, allowing you to do a better job of enhancing your schedules. If we look at our sensor, why is knowing the concrete strength critical? Well, concrete, when it reaches a particular strength, specifically in early strength, there's a lot of things that can happen next in the process, such as structurally removing the forms, and you want to be able to remove those safely when they reach the right strength in the concrete. Scaffolding removal, same concept. You don't want to remove the scaffolding too soon if the concrete hasn't reached a particular strength. Post-tensioning has to happen at a very critical strength, and knowing that is important when you're going to be post-tensioning your bridges and decks. Traffic release. DOTs want to release traffic as soon as they can, but if you release it too soon, bad things happen, right? You're going to be replacing that concrete a lot sooner than you would want to. Segment pouring. If you're pouring sections, columns, walls, you want to make sure that before you start adding the weight of a new section, that the base below it has reached particular strength and is strong enough to hold the new concrete. Tilt up in lifting panels. Very, very important to make sure that you have the right strength. You lift too soon, the panel will crack and crumble, causing a lot of problems in your process. And final payment. In a lot of industries, final payment is based on attaining a particular type of strength, and you don't get paid till you hit that strength. So knowing that is really kind of important. How do we measure strength today? Well, traditionally, over the last 100 years, we've been using compression cylinder brakes and flexible beam brakes. There's a lot of disadvantages to doing that. And the more people you talk to about cylinder brakes, I can't find a lot of people that really love that technology. It's time consuming, it's labor intensive, it requires really skilled technicians. If you're not making that cylinder properly and following the specifications, that's a problem. Getting skilled technicians to know how to do that today is getting more difficult. It's periodic. Cylinder brakes are typically done at 1, 3, 7, 14, and 28 days. It's not real time. So that's a problem. And there's a high potential for error. Studies have shown that as much as 500% error can be done high or low on what the actual true strength is in cylinder braking and beam braking. So if you compare cylinder brakes to the Rebel sensor system, how do we increase productivity? Well, the first one is labor time savings. We think that by knowing the true strength in real time, you can optimize your labor and better deploy them when they're needed. That immediately spells savings. You can set real-time alerts to when you hit a particular strength, knowing when to do something more efficiently. Equipment rental is dependent on a lot of things reaching strength, specifically like in tilt up. When you reach the strength, then you could schedule the cranes to come in and tilt up and lift the panels. knowing when that's going to happen makes it much more efficient so that you don't have equipment too late or too early, sitting around not doing anything. You can plan for weather. So if you know you're going to be at a particular strength on a day and you see bad weather coming, you can work around it. I know we can't do anything about the weather, but you might be better prepared for a bad weather day to do something to the concrete that's curing. It's a very easy system to deploy compared to making cylinder breaks. And we can start to predict 28-day strength and longer after 5 days. So when you're really trying to plan your schedule around getting to a particular strength level, we have the ability to know where it's going to be on what particular day. And that all these items mean that you can better schedule the efficiency of your operation. We delve deeper into the Rebel advantages. We look at that compared to cylinder breaks. Again, we talked about it being periodic, where the Rebel sensor system is buried in the structure, and it gives you real-time tracking of the strength as it grows. You can customize alerts to notify you when you've reached a particular strength. And when you know real-time strength, you're not going to miss a particular target day. So if you did cylinder break at let's say 1 day and you didn't meet strength, you might have to wait 2 more days to get to day 3. Same thing between 3 and 7, it gets worse as you go along. So knowing that real-time strength gives you a tremendous amount of power to know how to schedule your project efficiency. That it eliminates waiting periods. You get large-scale projects that can reduce your time when it all adds up to by more than a month. If you had a 30-story building, you could save a day, every time you do a pour, you can be saving a whole month by the time you get done with that building. That adds up to a lot of cost savings. And in a lot of cases, completion bonuses. If you can get the project done sooner, there are bonuses attached to a lot of programs. If you look at some of the key benefits of our system in different applications, in horizontal, we focus on accelerating the release of traffic and enabling early payment. A lot of the DOTs to be willing to pay their contractors faster as soon as they reach the strength of that was designed. And if you know when you've reached strength, then and get paid, sometimes you can get paid 2 to 3 weeks sooner than what's normally waiting for 28 days. In vertical, definitely cost savings and improvements in efficiency. We believe that our sensor system compared to cylinder brakes saves about 50% of the cost of cylinder brakes. In slabs, we can verify flexural strength along with compressive strength and reading temperature. It's easier to control the flatness of the slab as it's curing. In tilt-up technology, again, ensuring safe, confident lifting and lifting earlier are all things that are important to the tilt-up industry. Geotech houses that are maybe currently making cylinder brakes can switch over some of their cylinder brakes to our technology to increase their labor efficiency and boost productivity. In the ready-mix industry, I hear all the time about how the ready-mix industry feels that when there's a problem with the concrete on the contractor side, they have no way of confirming that it was a concrete problem that came out of their plant. So ready-mix companies can use the sensor to do quality assurance and quality control on what's coming out of their plant and comparing that to what happens on the contractor side. In the precast industry, it's all about removing forms as quickly as possible. The sooner you can move the forms, the more you can produce and increase your efficiency. And knowing exactly when the time is you've reached strength to remove those forms is incredibly powerful. And internationally, we're introducing this technology around the world right now. So how does the Rebel system actually work? A lot of our customers are certainly understand that cylinder brakes is nothing more than breaking a cylinder to look at the compression strength. Maturity sensors have been around for about 15 years. They measure the temperature profile of the concrete as it's curing, but that's really only good for about 20 hours until the concrete starts to cool off. We're using a completely different technology. We use wave technology created by a piezoelectric sensor. That wave is pushed into the concrete, and we're looking at the back pressure of that concrete as the concrete stiffens. If you were to look at the wave and on the left side, you see a graphic representation of that wave and the force behind it. When it reaches the point of resonant frequency, that resonant frequency has the lowest resistance of that wave. And you can see that wave right around 60,000 hertz just expand, just explode. If you graph that representation on the right side of this slide, you'll see that it peaks around 60,000 hertz and then decays. That peak is the resonant frequency of the structure, and all structures, specifically concrete, have a resonant frequency. And that resonant frequency is proportional to the modulus, which is proportional to the compressive and flexural strength. So if we look at concrete as it's curing and as it gets stiffer, its modulus and its resonant frequency will start to shift. We can see in this chart the representation of that resonant frequency peak actually moves to the right as the concrete gets stiffer. And we've represented the associated PSI from 120 PSI to 2000 PSI. And so we have created a very efficient means, non-destructively, in place to measure the resonant frequency and then ultimately the strength of the concrete in real time. Our sensors are very easy to deploy. You could just drop them on the ground and pour the concrete over it, or tie it to rebar and then pour the concrete over the sensor. As soon as the concrete is poured on the sensor, it senses that concrete and then starts recording in real time. The system is made up simply of the sensor, which has the piezo wave generator in it and a temperature probe. So we produce both strength and temperature. Has a 16-foot cable that can be extended up to 100 feet. And that plugs into the data logger. It's a one-to-one relationship, one sensor into one data logger. The data logger is what gives it power and activates the sensor and takes the measurement. There's an impedance meter inside the Rebel Sentry data logger, GPS location chip, cellular radio. We use cellular technology, LTM, to connect up to the internet and store our data. There's a lithium-ion battery included inside the Rebel Sentry. It goes up to 28 days. It uses wireless recharging capability, so there's no plugs that you have to plug into the device. That's allowed us to create a completely sealed case that can operate underwater. So it can take the environment of a construction site no matter what you throw at it. And it's got a very durable housing that can withstand a lot of environmental pressures. That system overall, when the sensor is placed into the concrete and plugged into the data logger, as soon as the concrete is sensed, then it is transmitting a signal every 15 minutes up to our cloud database. Within the database, we have a machine learning algorithm that works on that data to create the strength calculation, and then that's put into a user interface that a user can see on their phone, their laptop, a tablet, anywhere that they have internet connection. If you look more closer at our dashboard and user interface, it's pretty straightforward. We are presenting strength in real time as it occurs. You can set test points for when you reach a particular strength. At the same time that we're presenting the strength, we're also presenting the temperature, both at the sensor, the red line shows on the right-hand side the temperature of the sensor, and at the data logger, which is outside the structure, so it's kind of ambient temperature. So you kind of get the best of all worlds with our sensor technology. You get strength, you get in-place temperature, and you get ambient temperature at the same time. So just reiterating our entire solution, it's an embedded sensor that gives you real-time strength. that does not require calibration, is not dependent on temperature, can go the distance of 28 days or longer, very durable, and using a technology that can be sensed just about anywhere on the planet. Uses a machine learning algorithm that not only gives strength estimation, but can also start to estimate what the strength will be into the future after about 5 days. We do have an AASHTO certification T4112-24 that was just released the end of July this year. It's real time. We can accelerate construction schedules by knowing the strength as it occurs, which allows contractors to reduce their construction labor costs, potentially reduce cement usage when you know what your strength is going to be over time. We can eliminate the use of cylinder breaks or minimize the use of cylinder breaks. And overall, when you start eliminating cylinder breaks and can reduce cement usage, we can start to reduce the carbon footprint and do our best for the climate. And with that, I will turn it over to questions and open it up for discussion. Laura?
All right, thank you so much for that, Joe. We do have a few questions coming in. The first is, are the sensors reusable?
The sensors are not reusable. They're one-time use. They're buried in the concrete. They need to be completely encased in the concrete to function properly. The data logger that the sensor plugs into is the reusable portion of it, so that can go on to another sensor, multiple times. But the sensor itself is a one-time use.
Okay, gotcha. And the next question is, how might the Rebel sensor system change project planning, particularly in areas with extreme weather conditions that impact concrete curing times?
Well, as I said at the start, knowledge is power. So one of the things that I think helps, especially if you have to pour during bad weather, and you can start to see your real-time strength curve, you might better be able to plan around the weather, if you kind of know with our predictive ability where and when you're going to hit a particular strength level. That's number one. Number two is by integrating temperature into our sensor at the same time, you can monitor the temperature of the concrete. So if you're in extreme conditions where you had really high heat, you might be able to do something about protecting the surface to make sure that moisture wasn't evaporating off the surface of the concrete as it's curing. Or if you're in very cold conditions and pouring in the wintertime, you might be able to heat that structure so that you can maintain a particular temperature of the concrete as it's curing through its critical hydration stage.
All right, thank you. This next question is from Peter. What do you see as your biggest roadblock to making this technology more widely used in the industry?
Number one, I think that what we're trying to establish is awareness that people know that is available, that there is another alternative to cylinder breaks and maturity. So awareness is important. The second one is usage. We need more people to start to use the product and understand how it works. And then we need our contractors and our users to push it up the line to the owners of the project. That might be the DOT, it might be an owner who's buying a structure. We need groundswell support to push the technology. If we want this to succeed and expand it to the marketplace, we need users to use it and to then promote it in the industry and push it up the chain.
All right, this next one is from Suzanne. Could the Rebel sensors open up new opportunities for faster and safer project approvals from regulatory bodies? If so, how might this benefit the overall construction timeline?
Yeah, one of the things when you can see the strength, one of the I think dirty secrets in the industry is that we tend to over cement the concrete mix to guarantee that the cylinder breaks at the right strength. And if the cylinder doesn't break at the right strength, you either have to wait longer or you have to do a core sample, which is expensive, time consuming, and not what people really want to do. So one of the things when you can actually see the strength growing, you could, one, if if you can see that you're going to be overshooting, if your mix design overshoots the target strength, you might be able to limit the amount of cement that's used to lower your cost or lower the cost of the project and maybe win more bids. Or two, when you've reached strength, and it may be sooner than 28 days, in a lot of cases, we see horizontal mixes reaching strength in 7 to 14 days. And we have had a lot of support from many state agencies that said that once we get comfortable with the technology, we're willing to use the technology and use the information from the sensor, that if you can show that you've reached strength at a particular time, we'll be willing to certify that strength and pay you early. So wouldn't that be nice to be paid early if you were getting paid on strength a couple weeks sooner than waiting to 28 days? And right now in the industry, with a lot of the low carbon concretes that are coming on, strength is taking maybe 56 days to cure. So that means that rather than getting paid in a month, you might have to wait 2 months to get paid. If you can show that you've gotten to strength sooner, or with our technology can predict that you're going to get to the strength that's necessary in 56 days, maybe we can put pressure on the end customers like the DOTs to approve payment if you have a device and a tool that can show you that you're going to get to strength.
All right, thank you. Yes, it would definitely be nice to get paid early. Next question is, what are some unexpected cost-saving opportunities that might arise from the real-time data provided by the Rebel sensors beyond labor and materials?
Well, we just mentioned getting paid early, that's for sure. But if you can improve your efficiency, I think that allows contractors to both stay on target and potentially get finished with their projects sooner. There are, in a lot of cases, projects that have very, very tight time constraints. And due to that, there's performance bonuses paid in a lot of projects. And so if you can really see where your strength is, you can accelerate your schedule all the way down the line and be guaranteed potentially to be getting those performance bonuses. So it's a huge unexpected ability to get paid early. And having the tools in place, such as the Rebel sensor, allows you to benefit from some of those practices.
All right, thank you. We have a couple more questions here. This one is from Jason. How can the ability to monitor and predict concrete strength remotely with Rebel sensors lead to more efficient resource allocation on site?
I think that if we know where where the strength is going to be in predicting, and if you have an operation that is dependent on strength, knowing that strength, when it's going to occur, allows you to more efficiently schedule your labor, which is hard to schedule, to be at the site when you need them to do the next operation.
All right, thank you. And this is our last question. What impact might the Rebel system have on sustainability goals in construction, especially regarding cement use and reduction of concrete waste?
Yeah, there's, I think, some tremendous benefits in being able to help with carbon reduction using the Rebel sensor. For one, for sure, if you can actually see where your strength is going and what your mix design is going to do, you can start to optimize that mix design for lower carbon friendly concrete mixes by potentially reducing the amount of cement in the mix. As I said, industry standard is as high as maybe 25% over cementing in a lot of cases. Two, with the lower carbon concrete mix designs that are coming out today, 1L is an example where there's limestone in there, but also adding in a bunch of different types of SCMs, fly ash, slag, things that reduce the amount of cement as well, all change the strength over time curve. And our technology allows you to see how that is being changed and then react to it in a positive way. And finally, if you're using cylinder breaks right now, if you look at the concrete that's poured worldwide and the number of cylinders that are broken, those cylinders are using concrete. So right there, there is excess carbon being used with those cylinders. And then once those cylinders are broken and disposed of, they typically don't go into recycling, they go into landfill. But the carbon footprint just from cylinders alone probably represents about, in our estimation, a million pounds of CO2 generated on an annual basis. So, our goal is break free. We want to try and eliminate cylinders as much as we can. And by doing that, we'll immediately have an impact on the carbon footprint of concrete in the world.
Awesome. Thank you, Joe. And we just had one last question come in, so we'll get to that one real quick. When was this technology invented and by who?
The technology was invented by Dr. Luna Liu 4 years ago. Coincidentally, Indiana DOT came to Purdue University, where Dr. Liu is a assistant dean of the civil engineering department right now at that university. And they came to her and said, we're frustrated with cylinder breaks. They're not working well. We're frustrated with maturity sensors that can't really go the distance. Can you develop something that's better? And she is founded in concrete technology and was working with piezo electronics at the time. And she said, I think that would be a perfect solution, and went off and created it and proved that it has turned out to be a wonderful tool for use of this. We did field trials with the product all last year, and then we released the product just this year into the marketplace.
All right, excellent. Thank you so much, Joe, and thank you everyone for joining us today. Again, if you have any questions, go ahead and scan that QR code on the screen. Let us know how we can help, and be sure to go ahead and register for next week's webinar. We'll see you then.
Thanks. Bye, everyone.
Bye.